Welcome friends. In today's session of engineering drawing, we are going to study different types of projections with isometric projection and orthographic projection. Orthographic projection is again divided into two methods. One is first angle projection method and third angle projection. We are going to discuss in detail in coming slides the types of orthographic projection methods. First of all, see what is the orthographic projection. When the projectors are parallel to each other and also perpendicular to the plane, the projection is called orthographic projection. You may have seen in a cinema hall that the projector is not in a parallel, or the projector lines are not parallel to each other. Instead, they are inclined outward. So the small film is projected on the large film or the cloth of a cinema hall. Instead, here the projector lines are parallel to the solid or the component of machine. We can see it in the next slide or coming slide. I will show you. Here you can say the lines which you are seeing on the planes, whether on the first view or front view and top view and side view, you will see the projector lines, the rays are exactly perpendicular to the solid surface or this plane of a solid or a component of a machine element. So that, and in isometric projection, the isometric projectors or the lines, you can see in the next coming slide. Here I will show, are scaled at a particular ratio. Here you can see in the example 1, you can see this cylindrical surface. Even though the diameter is a circular, but in the view, isometric view, you are the shape of apparent shape of the cylinder and its sides is a oval shape. Instead, it should be a circular shape. You know that the cross section of a cylinder is circular, but in isometric view it appears like a oval. We are going to discuss one by one. First of all, look at the slide. Isometric projection is a type of pictorial projection in which the three dimensions of a solid are not only shown in one view, but their actual sizes can be measured directly from it. This is possible because of the scale, which the ratio which we are going to derive in the coming slides. Consider a cube shown in the next slide. Here it is. The three lines CB, CD and CG meeting at the point C and making 120-degree angle with each other are termed as isometric axes. Here you can see the lines CD, CD, CD and CG. These are making angle of 120 degree with each other. Here you can see. Okay. Then the lines parallel to these axes are called isometric lines. Okay, the lines parallel to the isometric axis are called isometric lines. Similarly, the planes representing the faces of the cube as well as other planes parallel to these planes are called isometric planes. You can see in the figure. Here the planes, let us say A, B, C, D, and the plane C, F, G, H, both are parallel, so they will be called as isometric planes. Coming to the isometric scale, as all the edges of the cube are equally foreshortened, the square faces are seen as rhombus. You can see the diagram. The A, B, C, D looks like a rhombus. And this ABCD shows the isometric projection of the top square face of the cube. Now construct a square BQDP. Then BP shows the true length of BA. You can see in the figure. Then the ratio isometric length divided by true length, that is BA divided by BP, will come approximately equal to 0.815. That is nothing but 9 by 11. Thus the isometric projection is reduced to the ratio 9 by 11. That is the isometric lengths are 0.815 of the true length. That means if the real size of a edge is equal to the 1 mm, then the isometric view and the isometric length of that particular edge will be 0.815 mm. Therefore, while drawing an isometric projection, it is necessary to convert true length into isometric length for measuring and marking the sizes. Now in the next slide you can see how these isometric views are obtained from the orthographic views. The very first two figures showing A, B, C, D and A dash, B dash, C dash like that are nothing but the orthographic views, top view and front view of a cube. And finally here at the right bottom corner you will get the isometric view of the cube. Let us now discuss what is the difference in projection methods of orthographic projection. There are two basic methods, those are first angle projection method and third angle projection method. In first angle projection method, object is kept in first quadrant. Before that you should understand what is quadrant. Look at this figure. Here you can see the quadrants. First, second, third and fourth. The space between these planes, frontal plane, horizontal plane and the first plane here on which the circular arrows are shown, this space is nothing but the quadrant. This space is nothing but the quadrant. Now coming to our slide. In first angle projection method, object is kept in the first quadrant, and in third angle projection method, object is kept in the third quadrant. While in first angle projection method, object lies between the observer and the plane of projection. Can you imagine? And if not, here you can see the second figure shows that. Here you can see first angle projection method, object is kept in object is kept between the observer and the plane, right? Object lies between the observer and the plane of projection. Likewise, in third angle projection method, the plane of projection line lies between the observer and the object. As we will go further, you will come to know what I am talking. Just read these and listen properly. In next coming slides you will come to know what it exactly means. Then in first angle projection method, front view is drawn above the XY line. You know the XY line, horizontal line which divides upper half and lower half of a plane. And in third angle projection method, front view is drawn below the xy line. It is always followed. This nomenclature or these rules are always followed. In first angle projection method, top view is drawn below the xy line, while in third angle projection method, top view is drawn above the xy line. Left view is projected on the right plane and vice versa. It is in first angle projection method, while in third angle projection method, left view is projected on the left plane itself. Don't worry, actually in India we follow only first angle projection method, so we need not to worry about these different differences in the projection method. While whenever you will face problem, you have to go or solve the problem in first angle projection method. This first angle projection method is followed in India and European countries, while third angle projection method is followed in USA. Coming to next slide. Here you can see the object is kept and their top view, front view and side views are given. First look at the third angle projection method and the figure shown at the top. Here you can see T represents the letter T represents the top view, F represents the front view. If front view is given on a particular plane, that means observer is looking from that side. Okay, and in third angle projection method we know that if a right side view is you have to draw, then it should be drawn on the right side of the front view, on the first figure on the top right corner you can see. While in first angle projection method, either it is a right side hand view or left side hand view. If we are looking from right side of the object, then the right side view should be drawn on the left side of the front view. Here you can see in the right bottom corner figure. While if we are drawing a left side hand view, then it should be drawn on the right side of the front view. How these diagrams came, I will explain you. Just look at the first angle projection method and the figure. You can see that there is a notation F, the letter F showing that front view. That means observer is standing and looking towards the object exactly from the opposite side of the frontal plane, so that front view will be on the frontal plane. Here you can see, and top view will be on the bottom side. Now what we will do, we will rotate this top view in anti-clockwise direction, and so that we will get it exactly below the front view. Here you can see in the figure at right bottom corner, like this every time we will do. Moving to the next slide. Here in this figure you can easily understand how these lines are projected and how front view, side view and top view are obtained. Here you can see the direction arrows are showing the direction of observer. Okay, here we can see that from the top there will be a top view, so it means that observer is seeing the object from the top. And now we will study the projection symbols. If we are drawing the particular object on sheet in first angle projection method, then this symbol should be drawn in the title block. So one can understand this complete sheet is drawn in the first angle projection method. Similarly, the second symbol is for third angle projection system. Here we have already discussed these quadrants. Now in this figure you can easily understand what I have already told you. Here you can see the left, the line, vertical line, and the plane associated with that line is denoting or used for the left view. That will be a right view. If we are watching a object from the right side, then we will get its projection on the left side. That is the vertical frame on the left side of the object. Here you can see the very first left side view in this projection drawn over in the left top corner.